A programming story. All desktop applications and smartphone apps are operating system specific. So if you develop an app for the iPhone, you will need to develop the same app again and from scratch for Android. And if you want to put it on the desktop, you will really need to redevelop it from scratch for Windows, Mac, and Linux. So you need 5 different development efforts, 5 different code bases, maybe even 5 groups of programmers to develop an application that does the same thing everywhere. Clever programmers figured out that they can just use the web browser as an application platform, since the browser already covered installing itself on all the operating systems. Getting everything to run on different operating systems is that challenging. And here, they can just write in JavaScript, the language of the web and the web browser, creating an app and application in one single language. Operating systems will frown upon this because they don't want a full web browser behind your app. In fact, they want you to be precise with your code. So precise that every bit of your application should specify if it needs a lot of CPU, delayed, slower CPU, or if it can just slowly run in the background whenever. When you drag an entire browser in here, everyone will eventually get mad. How dare you? The whole thing? Are you crazy? You should make 5 programs under 5 different architectures if you wanted the same thing to run everywhere. So the rational programmer decided to publish on the web. They will still need server-side code, or the back end, and code that executes in the browser, which is the front end. The user will often have to sign up, and they will get private space and can work from there. Kind of brilliant. Well, if the web application does something useful, that means it uses the CPU. Thing is, you just put all your customers on a single computer, the web server, that has all your code. So now you need a network of computers to handle the workload of all your customers. Haha. So you get 4 more really good servers. Now you have 5 computers, but you know what? With the same code. So it is not like you have 5 big separate projects. You just have 2. The server code that does something useful, and the browser code that gives the user a very good user interface. And as your program grows and gains in popularity, your servers crash. You lose data and customers on your biggest day. Your 5 computers could handle spikes, but not a huge spike like a Black Friday or Christmas sales spike. So, in your new startup, you get clever. You break down your programs into functions. And now, every time a user needs something done, a function is put on a queue server. And then a distant worker computer jumps in and solves that function, returning data in that slot. And when you get a huge and irregular inflow of users doing their processing, the system will absolutely detect that it is taking longer to solve the functions and will simply bring in more dumb servers temporarily. They are just regular machines that have a regular operating system, well, probably Linux, and all they do is talk to the queue, grab a function, execute that function to produce the result and put the result back on the queue and then go back to process something else. They don't need any special installation and hold no company data. When no longer needed, they are just erased, and some other customers can use them. This is called self-provisioning. You fairly pay for the spikes, and only when your servers are being used. You don't pay a monthly fee. There is latency, but the system is really nice. It's very manageable, and you can understand it really well. Small apps are still better off on a single server, but they will crash on a really good day. Self-provisioning is really nice, but we still have a dumb problem, because the server code is written in one language, Rust, for example, and the user interface is always written in JavaScript, as that is the language of the web. But we are in luck now, because Node.js, Bon, and Dino can run JavaScript on the server. This means a single code base is indeed possible. Code reuse would greatly cut down on complexity. Bye-bye Rust, or PHP, or Java. We are all JavaScript. It is very easy to write an HTTP server in Node.js, and same goes for cute queues and cool workers, reverse proxies that merge many HTTP services under one consistent roof. We are talking JavaScript solving all of our problems, which is amazing, because why do we even need servers now? Why don't we just wrap the entire application in a browser shell? Electron.js or NW.js do just that, and it is a browser and a server environment in an application framework that's based on a web browser, so you can have server code in there. You don't need the queues, but it is fine. It is all JavaScript. Again, companies like walled gardens and app stores will not like this, because you must ship 150 megabytes of web browser wrapped around your code. But you know what? At this point, you have no need for network. Your code is consistent and fine. In fact, kind of beautiful. You don't have to worry about hackers. Everything is installed on your customers' computers, so they bring in the CPU to the table. You can sell an enterprise version, where your customers can make a little self-provisioning network with your queues in their building. Hey, it runs in the browser. It does not strictly require the browser shell on the user end. Enterprise version has wiggle room. It has good flexibility. Companies like that because it saves good money. There's just one last thing. Your user interface. It will need an upgrade, even if just to bring it up to spec and make it look like the company expects it to look. And also, every few years, as technology evolves, you will have to refresh the user interface components. So you need a sturdy user interface strategy. That can mean React, Angular, Vue, Svelte, or doing something right from the beginning for a change, which is called vanilla JavaScript. To do vanilla, you need to become part human, part machine, part beast, and an ennobled creature, but one who not only does not shy away from dirty words, but actively invents or rediscovers new ones. And above all, is not afraid to speak them out loud. River cooter, a kind of a turtle. Skeezy, an old man that calmly watches you at the gym. Ermagerd Surge, a brand of bodybuilder workout singlets. Or the devil's ass, my private idea for a ghost pepper-based energy drink for bodybuilders and coders. It will make your ears tingle. You see, everything you see in the web browser is a tree, meaning it is built on the notion of nested elements. Every element, button, input box, text paragraph, contains a children array that can contain other elements. And those will also have a children array. You can nest things as deep as you need, as it makes sense. And when you have a key point in your application, you give it an ID. And then you use that ID to jump into that part of the tree. It's not a bad setup. These days, UI work goes pretty well as you have web components, meaning you can create buttons or even drop-downs and containers that perfectly fit into the existing browser environment. And yes, each is an object, so it has internal memory, graphic styles, and it will do what you need it to do. And it does have that children array where you can nest things ad infinitum. You can have a login web component that just requires one line of code to display and plugs in really well into your authentication system. Working with the big tree requires some getting used to. It takes a while. But once you can handle it, frameworks that abstract this away seem crazy. They only create a tree on top of a tree anyway, and that is just freaking madness, especially now that the concept of signals became popular. A signal is just a variable, like x in math, but parts of your program listen to it and self-update whenever x changes. Good stuff, really good stuff. Final quirk is when you rely on two or more signals, let's say X, Y, and Z, and they just each hold a number. What we are looking for is being notified when any of them change. Once they are not null, so once they are initialized, and actually have a number. And yes, any time after that, whenever any of those three numbers changes, a new notification must be sent out. Indeed, this is a challenge at first. Signals really are to die for, but you do pay for it. Because change is not sugar and spice and everything nice. It is change over time. And only after each of the numbers are valid. And monitoring must stop. And it is better when it does so automatically when that part of your program or user interface is no longer active. In a word, you must unlisten when that part of your program is going away. Yeah, signal dues. But again, it is worth it. It is a marvelous invention, and it's only like 5 lines of code internally. You change a signal, and your entire application just automatically updates. The last bit of good news is that combining signals only sucks when programming the old way with code. XYZ is a simple example. Usually there are going to be several layers of change, and it's going to be really hard to keep track of everything. In a visual programming environment, where a signal can be represented with a box, and our x, y, z with 5 boxes, x, y, z, combine latest, and x, y, z, the result, and all the boxes are connected with lines, x, y, z is plugged into the combine latest, and the output of combine latest becomes the updated value of the XYZ signal. The workflow is also good. Let's say that in the beginning you just drop a button on a canvas or in a form. And when you double-click that button in a development environment, you simply enter the visual programming mode. And now you can change signals throughout your application. You just drag them out of somewhere to make all kinds of things happen everywhere. A signal can control accordion panes. A signal can control the user profile box in the upper right corner. A signal is not just a number, it can hold a complex object. So it's in charge of anything and everything. It is not the best way to control applications, but it is the best way to do so simply. And what more could you possibly ask for? A signal is just a cute little pocket. And this is where our story stops. It's a beautiful ending, a visual programming environment. We rose from 5 different code bases on 5 different devices to just 5 different boxes. We rejected walled gardens, aka app stores, as a ridiculous and absurd idea, and created a self-provisioning enterprise masterpiece that will save a ton of money. And on top of everything, it has a visual programming front end that routes clear-to-grasp signals and updates the user interface components by just setting values automatically. Don't ask what you would make with it. Don't do that. Sell it as it is, as a development environment. It's up to your customers to make stuff with it. They will each have a different aim. In a way, this reflects our journey back to the desktop, where we don't need servers anymore, because everything is written in JavaScript, a single language, and the customer can now execute it on their computer, bringing in their own CPU, thus eliminating the need for an expensive central server network.